Page 476, continuing lesson 8.4 on frequency tables and histograms. When we talk about intervals in this section, intervals is how many possible numbers are in a group. So, for example, if you look at this key concept, they looked at the bags of popcorn that were sold each day. They're going actually by intervals of 10. The first group is from 30 to 39. If you look at it 30 to 39, you might think it's 9 numbers, but actually if you count it out from 30 to 39 is actually 10 different numbers. So again, just showing you here how on the key concept you can take the information and you can organize that into a frequency table. Here they were going by tens and they had 4 groups. And then once you've done that, you can make your histogram. Remember, on the histogram, the bars are right next to each other than if there's a gap. Like here, there weren't any in the 40s. So there's a gap. There's no bar there. So if we look at the do you know how, number 5, they have already started this frequency table for us. So eventually we will look at one where we're actually doing the frequency table from scratch, which is a little more realistic of what's going to happen, but this one is already set up for you. So it's up to you what you want to do. I like to just go along as the numbers are and put my tallies. So there's a 6, there's an 11, there's a 9, 13, and so on. Okay, so I like to just do the tally mark and then cross it off. So I know I've taken care of it. Okay, and then once you've done that, if we've done this correctly, we can do our frequencies, just how many tally marks we have. So 2, 5, 2, 2, and 1. And then from there we can make our histogram. I'm going to move this over so we can see both things at the same time. We'll put it over here. Notice on the histogram they've also already done some of the work for you. They have a title and they have labels. They have ages listed at the bottom and then they have number of people listed on the side. So we just need to fill in some information here for the ages, just like they had on the frequency tables. Should be 6 through 10, 11 through 15, 16 through 20, 21 through 25, and 26 through 30. And those are actually going in groups of 5, intervals of 5, even though they might look like 4s to you. And then for the number of people, if you look at the frequencies, the highest frequency we have is 5. So we should be good just to go by ones here. 6 would be this top line at the very top of this thing. So 6 through 10 has 2. And we'll start right next to that vertical axis with that box or that bar. 11 through 15 has 5, and we'll put that right next to the previous bar. 16 through 20 has 2. 21 to 25 has 2. And 26 through 30 has 1. So this is what our histogram should look like. We'll look at workbook page 115, number 3. The question is how many students are in the PE class? Look at the directions above that first of all. It says use the data in the frequency table. The frequency table shows the time it took students in a PE class to run 1 mile. All right, so basically they're telling us for different intervals, different 1-minute intervals, how many people it took that amount of time to run 1 mile. So to do that, figure out how many students there are altogether. We can either add all the tally marks together, or we can add these frequency numbers together. If you add those together, 6 plus 2 is 8, 8 plus 8 is 16, 16 plus 6 is 22, 22 plus 9 is 31. So it should be a total of 31 students in the PE class. Number 4, how many students ran 1 mile in under 9 minutes? Under 9 minutes. So if we look at this, there's only one group here, one interval that's under 9 minutes. And so we can see from that there were 6 students that ran a mile in under 9 minutes. Number 5, it asks how many fewer students ran a mile in under 10 minutes than the students who took 11 or more minutes to run that distance. So it's kind of 3 different parts to this question. First, we have to figure out how many ran the mile in under 10 minutes. We have to figure out also how many that took 11 or more minutes, and then we have to find out what the difference is of those. So under 10 minutes, let's look at first of all. So for under 10 minutes, that would be the first 2 groups here. The first 2 groups were under 10 minutes. So that's 6 plus 2 is 8. So under 10 minutes, I'm just going to go to the side here for a minute. Under 10 minutes. There's 8 of those. And then 11 or more minutes. 11 or more minutes. So that would be these last 2 groups here. 11 or more minutes. So 11 or more minutes. We did the last 2, which was 6 plus 9 is 15. And then the question is how many fewer students ran a mile in under 10 minutes than the students who took 11 or more minutes. So if there were 8 that were under 10 minutes and there were 15 that were 11 or more minutes. So we need to take the difference of those. So 15 minus 8 is a difference of 7. So 7 more students, or 7 fewer students ran under 10 minutes than 11 or more minutes. Number 6 asks, can you tell from the frequency table how many students, if any, ran a mile in exactly 12 minutes? So if we're looking at this, can we tell how many people, if anybody, ran in exactly 12 minutes? And the answer is we know that 9 people ran between 12 minutes and 12 minutes and 59 seconds, but we can't tell exactly in exactly 12 minutes. So we could say something like, no, the frequency table shows intervals of times, not exact times. Okay, so we know an interval, or a range of, 12 to 12:59, but we don't know exactly what their times were. So this next part, they are talking about the ages of players playing miniature golf. So they've got the information. They made that into presumably first a frequency table and then a histogram. Number 7 says, just as Lila finished making her histogram, a group of 5 people started playing. She wants to include their ages, which are 12, 12, 16, 26, and 48. How should Lila change her histogram to include these ages? So our lowest group is 6 to 15, and if you look at the numbers, these new players we have, there are both of the people that are 12 years old would fall in that group. So we should add 2 to the 6 to 15 interval. Our next interval, 16 to 25, we have a person that's 16 years old, and that's the only one. So we'll add 1 to the 16 to 25 interval. So we have a 26-year-old that would be in the 26 to 35 interval, so we would add 1 to that interval. There's nobody 36 to 45 that's new, but then we do have one that's 48, so we would add 1 to the 46 to 55 interval. Number 8 says Lila recorded the ages of the miniature golf players at 3 o'clock p.m. How might her data change if she recorded the ages of players at 7 o'clock p.m.? So there's different possibilities here. Maybe at 7 o'clock, maybe it's more crowded, maybe it's less crowded. But we're talking about with the ages of the players here specifically. Possibly there could be more people who are 26 to 55 years old because they might be off of work at that time. Just depending where people work. A lot of different businesses maybe close at 5 o'clock or something like that. So 3 o'clock they'd still be working, whereas 7 o'clock they would have been off work and maybe had a chance to eat something and then go to play miniature golf. Again, lots of different possibilities here. There's not really just one correct answer for that problem. Number 9, suppose a 65-year-old brings her 2 granddaughters to play miniature golf. The granddaughters are both 5 years old. How can Lila adjust the intervals to include these ages? So right now, the lowest interval starts at 6 and the highest interval ends at 55. We're going to have to go both directions here. We have a 65-year-old and we have people that are 5 years old. And part of the problem is our smallest group right now, our smallest interval is 6 to 15. So 6 to 15, we have somebody younger than that. We're going in intervals of 10. So if you go by intervals of 10, we can't just sneak in an interval that goes from 0 to 5. That would only be 6 numbers. So we kind of have to just readjust everything. 0 to 5 is not a big enough interval with how we have our other intervals set up right now. So a couple of ways we could do this. One way would be we could go by tens starting from 0. So that would be our intervals for that if we did it that way. That would include everyone. And another option, we could start at 5 and go by tens, and then that would make it end at a little bit higher number. Again, we just have to make sure that we're not excluding anybody. We have to make sure we're starting at least as low or lower than our youngest person, and then at least as high or higher than our oldest person here. So again, those would be some options, and it kind of, we just have to readjust the whole thing. We can't just, sneak in somebody, a group, an interval from 0 to 5, because that's not as big of an interval as the other ones that are going by tens. Then if we look at number 10, each day for a month, Bo timed himself to see how many free throws he could make in 60 seconds. Using the histogram, select all of the true statements that describe Bo's data. So I'm going to try and move this here so we can see both things at the same time. So the first statement says there were 31 days in the month. So if we look at our bars, we can see how many times he got each of these amounts. So 6 times, he got 0 to 4, and then 8 times, 11 times, 5 times, and 1 time. So if you add those numbers together, they actually do add up to 31. So there were 31 days that month. So the next statement is whether Bo made 15 to 19 free throws 6 times. And if you look at that bar, 15 to 19, actually 15 to 19 he made 5 times, not 6. So that doesn't work. The next one says more than half of the days in the month Bo made at least 10 shots. So if we look at these, at least 10 shots, that would include the 10 to 14 interval, which happened 11 times, the 15 to 19 interval, which happened 5 times, and the 20 to 24 interval, which happened 1 time. So if you look at that all together, 11, 5, and 1, that's a total of 17 times out of the 31 days. That's more than half, and so that works. The next one says the greatest number of shots made in 60 seconds was between 10 and 14. So this one, we did some problems like this in the book. The greatest frequency of shots made was between 10 and 14, but the greatest number of shots that he made was somewhere between 20 and 24. So that one doesn't work. And then the last one, Bo made fewer than 10 shots more often than he made more than 14 shots. So fewer than 10 shots, that would be these first groups here. So that's 6 and 8 is a total of 14. And then more than 14 shots. So that would be these last 2 groups here. So 5 plus 1, which is a total of 6 times. So fewer than 10 shots happen 14 times more often than more than 14 happen 6 times. 14 is more than 6, so that works. So this gives you an idea of how to work with frequency tables and histograms.